Benefiting from that is Inversion Sensor. They're working on a next-generation fire detector. As you see here, traditional fire alarms have to be installed every few feet, depending on the relevant building code. Up until now, Inversion Sensor has made optical fiber-based detectors that monitor building stress and deformation. And right now, they're busy installing those in the soon-to-open IT-focused tower in the Academ Park. However, the company is pushing that technology one step further. It aims to take optical fibers and use them in a new kind of fire alarm, which they say can be more cost-effective and in some cases safer.
We propose using optical fiber as the sensor development to measure temperature along it. This way, optical fiber can act as a fire signal. For large lengths, it can be very economically effective. Furthermore, our sensors are absolutely spark and explosion-proof. Therefore, they can be used in coal mines, chemical industries and so on, where traditional electronic sensors are forbidden.
In this room, we're developing and researching our distributed fiber sensor. We're currently at the final testing stage. It's important for us to understand what the maximum distance is at which we can monitor the temperature and what resolution we can get. To increase the distance here in the lab, we use these spools of fiber. Of course, this isn't the same fiber that you saw being installed earlier. A bundle of this cable would weigh around 200 kilograms, and we don't need it since the fiber on the inside is the same as it is here. This fiber goes along the wall from one spool to another, and eventually reaches our device. In total, we have about 6 kilometers of fiber here. The section of the fiber we want to affect is located inside the kettle. There's 10 meters of fiber here, so when we turn the kettle on, we can observe the water temperature increasing in real time. We see processed results on this screen. There are 3 charts. The first one shows data from the signals coming in. The second, the calculated temperature. And the third, the relationship between temperature and time.
Here on the screen, we can already see some kind of peak, right?
The peak is the water temperature inside the kettle. We can even see it in more detail. These peaks are processed by our device, which then determines whether a fire took place or not.